Hi, today we are going to talk about chemical bonding, grade 10, term 2 topic. And then if you remember last time we talked about, what type of forces do we have? What type of forces do we have in chemistry? Intermolecular forces and intramolecular forces. And then if you imagine a glass of water here, if you imagine a glass of water here, and then if you take H2O molecules, if you go to the level of, H2O molecules, what you are going to see is that there are two types of forces. The one type of force is the one between the elements inside of the H2O molecule, one oxygen and two hydrogen atoms. These are the ones what we call as intramolecular forces, the forces between the elements inside of a molecule. And there is another type of force that keeps H2O molecules together, and then that is related to their physical properties, like their phases, depends on like boiling point, melting point, depends on this type of force. That's what we call intermolecular forces. And then today we are going to talk about one type of intramolecular forces. And the other name that we discussed before, if you remember, the chemical bonding is the other name for intramolecular forces, is the type is what we call as a covalent bond. We are going to talk about covalent bond. So when you look at the definition of covalent bond, let's start with definition, and then we can talk about some important properties about the chemical and the physical properties of the substances that has covalent bonds. What is a covalent bond? As the sharing of electrons between atoms to form molecules, While they are sharing, they form a bond. Bond is, as you know, that it's not a physical structure, Like holding two ends each other, and then they're having a bond between each other, like attaching something into another thing, So it's actually an invisible force, electrostatic force between positively and negatively charged particles. And then we said that if you want to talk about the types of chemical bonds, and then we have three types, and then we differentiate these types by using their type of elements. When you talk about, I'm trying to say that when you talk about covalent bonds, we have a non-metal, non-metal, and then that goes into a chemical bond with a non-metal, When non-metal bonds into a non-metal, another non-metal, that's what we call as a covalent bond. And then both of the non-metals, because of their chemical properties, they like to take electrons, and then both of them like to take electrons, is that none of them wants to give electron. And then what will happen is that both of them take the electrons, and then is sharing of electrons, So one non-metal gives one electron, for example, another non-metal gives another electron, and then these two electrons, imagine that these are electrons, is going to be shared between these two non-metal atoms, and then they will become like a noble gas structure. They will become stable, And then another definition that I like to talk about today is the molecule. What is molecule? A group of two or more atoms that are covalently bonded, which means that group of atoms are the ones non-metals, And then that are covalently bonded, which means that they share electrons when they make chemical bonds, and that functions as a unit. For example, for this is like carbon monoxide, carbon and the oxygen on the right hand side of the periodic table, and they are non-metals and they make bonds. And another one is carbon dioxide. It's a carbon dioxide molecule, H2O. This one is, and H is on the left hand side of the periodic table, but you know that it's a non-metal. And oxygen is on the right hand side of the periodic table. That's all in a non-metal, non-metal, and non-metal. And then this structure is what we call as covalent structure. That's the name is the H2O molecule, carbon monoxide molecule, and carbon dioxide molecule. And what are the important properties about the structures with covalent bonds, And they are not very soluble in water, They don't dissolve in water easily, And then because of this, they don't like to dissolve in water. They are poor or non-conductors, So what I'm trying to say is that, okay, if they dissolve in water and then if they release ions in water, they will start conducting electricity, okay? And then because of that, they don't like to conduct electricity. And then I'm talking about H2O, okay? Pure water is a non-conductor, okay? Pure water is a non-conductor. And then share bonding electrons, okay? And then these two electrons, if you remember on the left hand side, I just discussed, that is given by one and another one shared between these two non-metal atoms. That's what we call as bonding pair of electrons, okay? Bonding couple of electrons. And then they share these electrons. And they have very low melting and boiling point. One indication, okay, one example of this is what we call as they are usually at gas phase. If you look at the right hand side, like H2, Cl2, and then F2, okay, and then O2, okay, N2. These are covalent structures or covalent molecules, and then they usually have low melting and boiling point. That's why at room temperature, at 20 degrees Celsius, they are at gas phase. And then they can be gas, liquid or solid at room temperature, yes, but mostly they are at gas phase, okay? For example, there's something called Br2, it's bromine water, okay? Or they can be also in the solid phase, okay? And they are composed of molecules. Molecules are the structures when the covalent bond is formed, okay? And then no charged particles here. And then we don't have like ions, positively and negatively charged ions interacting with each other in this case. And what happens is that they share electrons, okay? And then now we are going to talk about covalent bond and their structures. How do we represent covalent bonds in a simple way, and then we can understand how do they share electrons? Is one way what we discussed in the previous class is the Lewis dot diagrams. Okay, Lewis dot diagrams of a simple covalent molecules containing single, double, and triple covalent bonds. What is single, double, and triple covalent bond? Before we discuss the shapes and before we talk about the Lewis diagrams, okay? And the single bond, covalent bond means that there is a pair of two electrons shared between two atoms, okay? If you have 4 electrons, which means that one atom gives 2 electron and another atom gives 2 electron, and then in total we have 4 electrons shared, that is equal to a 2 pair. So which means that if you have between 2 atoms that is shared 4 electrons shared, 2 pair of electrons shared, that's what we call as a double covalent bond. And what is a triple covalent bond? If you have 6 electrons shared between 2 atoms, which means that 3 pair of bonding electrons we have between 2 atoms, that's what we call triple covalent bond. So a single covalent bond represents a pair of electrons shared between atoms, okay? And then in a Lewis dot diagram, 2 dots between the atoms represents a covalent bond, okay? It's a single covalent. If you have 4 dots, okay, which means it represents 2 pair of electrons, okay? That's equal to what we call a double covalent bond, okay? If you have 3 pair of electrons, that is a triple covalent bond, okay? And then it's stronger than double and single one. And these 2 electrons are known as bonding pairs, okay? There are other electrons that's not involved in the bonding. They are not shared between the atoms. Still they're around the atoms. That's what we call non-binding electrons, are called lone pairs. So let's look at one example. When I look at the example of hydrogen, when we look at the periodic table, let's go to the periodic table. And then when we look at the hydrogen here, okay, let's find the hydrogen here. It is here. And then what is the number of atomic number? As you remember, we use atomic number for this. Number of protons is 1. Okay, let's go back. So we have number of protons is 1. Okay, that's equal to number of electrons, because that we said that in covalent bonding we don't have positive and negative charges. Okay, so it's just neutral at all. If it is neutral, we have equal numbers of protons and electrons, that's equal to 1. So if we have 1 electron, if we write down the SP notation for this, so that's going to be 1s1. Okay, what is the last energy level? 1. That's the only energy level. And how many electrons? 1. You just need to show 1 electron around the symbol. This is our Lewis diagram for single, okay, neutral hydrogen atom. Okay, so that's going to be hydrogen and 1 dot around it. And then imagine that there is 1 hydrogen and plus there is another hydrogen, and the second one we use cross to be able to show the electron. Okay, and then we can see which electron gives which electron. Okay, which electron comes from which one. That's why we did it like this. And then when they make chemical bonds, okay, and then what is going to happen? Okay, what will happen is that, okay, this one is given by the left hand side one, and this one is given by the right hand side one, and these two electrons are going to be shared between these two electrons. And then there is a rule that I discussed in the previous class, if you remember that. Okay, why do they take electrons? Why do they share electrons? The reason behind that is what we call as octet rule. Okay, octet rule. And then what does octet rule says? Okay, if you have elements like hydrogen and helium, okay, if you have elements like hydrogen and helium, okay, helium, I'm trying to say helium, they like to have 2 electrons. Okay, they like to have 2 electrons in their last energy level. Already helium has 2 electrons in the last energy level, and it's a noble gas, it's a stable atom. What about hydrogen? It doesn't have 1, it only has 1. So it needs to take 1 electron from outside to be able to look like helium atom, and then it will become stable. It's an unstable until it has 2 electrons. Okay, that's what we call octet rule. What about other elements? What we can say about other elements? Okay, so all other elements, okay, they need to have 8 electrons. Okay, 8 electrons in their last energy level. If they have 8 electrons, they will become like noble gases and they will become stable. That's why they want to make chemical bonds. Okay, that's called octet rule. So to be able to have each one, this one needs 1, okay, this one needs 1 electron, and this one needs 1 electron from outside. So what do they do? This one not, this one cannot, and this one cannot take or give. And what do they do is both of them they want to take, and what do they do is that they just share electrons. So which means that these 2 electrons belongs to the one on the left hand side, at the same time belongs to the one on the right hand side. Okay, and then what happens is that these 2 electrons are called bonding pair of electrons. They are called bonding pair of electrons. Okay, and then instead of showing these 2 dots, okay, 1 cross 1 dot, what you can do, you can just draw a line. This line is representing a covalent bond, or it also represents a pair of electrons shared between 2 atoms. Is there lone pair of electrons here? No, because there might be some other atoms around atoms that's not shared between them. Okay, and then in the next example, I think we are going to see examples of lone pair of electrons. What about fluorine atom? Okay, I'm talking about F2, structure F2. We just discussed the structure, the molecule, hydrogen molecule H2. What about F2? How can we show F2? When we look at our periodic table, I just want to take you to the periodic table. Let's make it bigger. On the right hand side, if I'm not mistaken, it's in group 17. And then what do I need to do? I need to know the atomic number for this. When I take the atomic number for this is 9. Okay, it is 9, which means that now we have 9 protons in this atom. So when I come back here is that, okay, so if it's a neutral one, it's covalent bond, we said it's neutral. There is no positive and negative, okay? No positive and negative charges. Neutral, which means that we have equal numbers of protons and electrons. And that one means that we have 9 electrons. And then if I write down the sp notation, 1s2, 2s2, 2p5, okay? We know that s orbitals must get maximum 2 and p orbitals maximum 6. And then 2 plus 2 plus 5, 9, okay? And what is the last energy level? Okay, the numbers in front of orbitals is showing us the energy level numbers, 2 and 2. And how many electrons we have? 2 in the last energy level, 2 plus 5, 7 electrons. So I need to show 7 dots around the fluorine, as we did before in the previous classes. F, 1, 2, 3, 4, 5, 6, 7, okay? This is our neutral fluorine atom. Okay, the Lewis diagram. Imagine that one if fluorine atom and another fluorine atom, they come together and then they want to become like noble gases, and we said that except hydrogen and helium, this is except hydrogen and helium, all others they would like to have 8 electrons. So to be able to have 8 electrons, this one needs to take 1 electron from outside. Okay, that's possibility. And this one needs to take 1 electron from outside. When they make bonds, okay, one cannot give, other one cannot take, because they have the same ability to for attraction. They are the same atom. So instead of taking and giving, what they do is that they share the electrons. Okay, this electron is given for sharing and this electron is given for sharing, and they share this electron. So which means that, okay, these 2 electrons, as you can see in the middle, these 2 electrons belongs to the one on the left hand side, 2, 4, 6, 8. So it is a noble gas structure, so it's stable now. And at the same time, the ones in the middle belongs to the one on the right hand side, 2, 4, 6, 8. So which means that it is stable now. Okay, so and then that is what we call as covalent bond. And another 2 points that we discussed just now, lone pair and bonding pair of electrons. How we can show bonding pair and lone pair of electrons? The bonding pair of electrons are the ones in the middle, okay, between these two, shared by between these two, there is one pair, okay, one bonding pair. Can I just use BP for bonding pair of electrons? And around this fluorine, how many lone pairs that's not shared between the atoms? Okay, these are not shared between the atoms. It only belongs to the one on the right hand side. 1, 2, 3. So we have 3 lone pair of electrons. Pair means 2 electrons. Okay, we know what's pair. 1, 2, 3. And this one also has 3 lone pair of electrons. So instead of writing, okay, instead of using these 2 dots, I can draw a line also. That's also same thing. Both of them are same. That line represents a pair of bonding electrons, and that represents a single covalent bond. Okay, single covalent bond is 2 electrons shared between 2 atoms. That's what we call a single. If you have 4, you have 2 lines. That's double covalent bond. If you have 6 electrons shared, you have 3 lines. That is triple covalent bond. What about some other structures? For example, I said group 17 elements, Cl2. Okay, how can I show Cl2? Chlorine gas molecule. Okay, I'm talking about chlorine gas. I want to show Cl2. Okay, how it is formed by using Lewis dot diagram. Okay, so when we look at Cl2, I'm just going to take you to the periodic table, and then if you look at the periodic table, what we see is that Cl is on the right hand side and it's in group 17. Like fluorine, you remember how many valence electrons we have in fluorine? 7. And chlorine is also 7. Okay, how do I know that? It's a shortcut. Bromine, okay, is also 7. Okay, because all group 17 elements, they have 7 valence electrons. What about group 16 elements? They have 6 valence electrons. Group 15, they have 5 valence electrons. Group 14, they have 4 valence electrons, all of them. Okay, group 13, they have 3 valence electrons. If you remember, we don't deal with the one in the middle. Okay, so we are just going back to group 2. Okay, and then group 2 elements, they have 2 valence electrons always. Okay, group 1, they have 1 valence electron. So I'm going to use this shortcut from now to make it faster for us. Okay, so chlorine, 7 valence electrons. If you want, you can write down the SP notation and then you will find the same answer. Okay, so when we look at Cl2, okay, so 1, 2, 3, 4, 5, 6, 7 plus another one. Other one we use cross, so we will see which electron is coming from which one to be able to be shared between them. Then they make chemical bonds. Why? Because this one has 7. All other elements except hydrogen and helium, they need 8 electrons. To be able to have 8 electrons, this one needs from outside 1 electron, this one needs from outside 1 electron, and then both of them, they have same ability because it's the same element. They have same ability of attraction. So one cannot take, one cannot lose electron. What do? They share the electrons. That's what we call non-metal covalent bond. Okay, so this one is coming from the one on the left hand side, the cross one is coming from the one on the left and right hand side. So which means that, so these, the one on the left hand side has 1 2 3 4 5 6 7 8 electrons. So now it is stable like noble gases. And the one on the right hand side has 1 2 3 4 5 6 7 8. So the one in the middle is like belongs to both of them. Okay, that's what we call shared electrons. And instead of showing 1.1 cross or one double dot or double crosses, okay, what you can do, you can just draw a line. This one represents a pair of electrons, bonding pair of electrons. So how many bonding pair of electrons do we have in this structure? If I ask you this question, and then you can easily tell me, I can see that, and then you will easily tell me that. I'm trying to use another color. Okay, there is one bonding pair of electrons. BP represents bonding pair of electrons. The electrons shared between, okay, a pair of electrons shared between the atoms. And there is 1 2 3, that's not between the elements. So that we have around the one on the right hand side, the chlorine on the right hand side has 3 lone pair of electrons. The one on the left hand side has got 1 2 3. It also has 3 lone pair of electrons. Sometimes what we do is that if we want to focus on only the chemical bond and then how many bonds we have between the chlorine and chlorine, we just ignore the other dots. But I advise you to use this one. Okay, so later, inshallah, in grade 11 and 12, we are not just going to ignore, because we already know that they have 3 and 3 bonding pairs, and then we just to show the chemical bonding. That's what we call Cooper notation. Okay, and when we look at the next one, oxygen. O2, I'm talking about O2. I'm going to show you O2, oxygen molecule. As you see, this is in group 16. So how many valence electrons we have? 6. I'm just trying to go back. Okay. So how many? 1 2 3 4 5 6. Okay, this one 1 2 3 4 5 6. Okay, they go into chemical bonds. Okay, because this one needs 2 electrons from outside to be able to obey the octet rule, and then it will become stable. This one also needs 2. What do they do is that this one gives that 2 here, and this one gives that 2 here, and then what happens is that they share this 2 and 2. So which means that these 4 electrons between the symbols belongs to the one on the left hand side, at the same time belongs to the one on the right hand side. Shared electrons. Okay, they use it together. Okay, so which means that the one on the left hand side has 2 4 6 8 electrons. Now it is stable. The one on the right hand side also at the same time 2 4 6 8. Okay, both of them are stable. Instead of showing a pair of electrons by using cross and dot, you can just draw a line and another line. So this one tells us there is double covalent bond. This is called 2 lines represents double covalent bond, which means 2 pairs of electrons are shared, okay, between the atoms. And how many bonding pairs do we have in oxygen molecule? If you ask me, and then I can tell you that 2 bonding pairs of electrons. How do we know? Those electrons between the atoms. And what about the other electrons, okay, around oxygen that's not shared between the oxygens, okay, that's lone pair, okay, and then we have 2 lone, this is L, pair of electrons on the one on the right hand side. On the left hand side also we have 2 lone pair of electrons. Okay, that's how we can talk about oxygen gas. Okay, oxygen molecule. This is the oxygen molecule structure. What about the next one is the N2, the nitrogen gas. Okay, when we talk about nitrogen gas, both of them are non-metal. They like to share electrons, non-metal and non-metal. We know that covalent bond. And then what we need to do is that I just want to take you to the Lewis diagram. Periodic table. I'm taking you to the periodic table. When I look at this, okay, so this is group 15, and then we see 5 valence electrons. We just said that group 15, 5 valence electrons, or what you can do by using 7, you can write down the SP notation and find that there are 5 valence electrons, and then there are 2 core electrons, because in total we have 7 electrons in neutral nitrogen atom. So, which means that in Lewis diagram, you remember that we need to put 1 dot for each valence electron. 1, 2, 3, 4, 5. And this one we use crosses, and then we will see which atom gives how many electrons to be able to share it. And then they go into chemical bonding. And this one needs how many? 3. Okay, this one needs how many? 3. What happens is that this one gives 3, this one gives 3, and they share these electrons. Okay, and then if you look at this circle, and then this circle is the one on the left, the one on the left, nitrogen has got now 2, 4, 6, 8. So this 6 electrons in the middle is shared between the one on the left and the right hand side. That's what we call chemical bonding. Okay. And at the same time, the one on the right has also 2, 4, 6, 8 electrons. Now it obeys the octet rule. It's stable now. And then instead of using crosses and dots for electrons, and then what we can use for a pair of electron, at 2 electrons, we can use a line, 1, 2, 3. We have 3 pairs of electrons shared. So 3 lines, which means that this one is triple covalent bond. Okay. And then how many bonding and lone pairs do we have? As you can see between the atoms, okay, we have 1, 2, 3 pairs, okay, which means that 3 bonding pairs. Those shared electrons are called bonding pair of electrons. What about the one on the right hand side, the nitrogen? And then we have 2 electrons, that is 1 pair. It's not shared between the atoms. That's called lone pair of electrons. As you can see, lone pair of electrons. Bonding pair of electrons, okay? And this one is also another on the left hand side has got also 1, okay, lone pair of electrons. These are the Lewis diagrams for nitrogen gas, oxygen gas, and chlorine gas. What about if you have two different elements? How can I show the Lewis diagram? Okay, not like H2, Cl2, Br2, I2, okay, N2. So we have 1 H and F, okay, the one on the left hand side. Let's look at here. So hydrogen and fluorine. I just want to take you to the periodic table. Let's go to the periodic table. Let's identify. Hydrogen is in group 1 valence electron. Fluorine is in group 17 7 valence electrons. So fluorine is going to have 7 dots around it. Hydrogen is going to have 1 dot. So hydrogen has got 1 dot, okay, like this. Okay, plus fluorine has 7 dots around it. Okay, that's the original neutral atom. Okay, 7. And then when they make chemical bonds, what happens is that this one needs how many? One more electron. Why? Because hydrogen and helium is a special case. They want to have 2 electrons to be able to look like noble gases, and they will become stable. Now it's stable if it has 1 more electron from outside, and the fluorine has got 7 and it needs 1 more. All others, if you remember, 1 more. So what happens is that this one gives 1 electron to be able to be shared, and the other one gives another electron, and then they share these 2 electrons. So actually there's a line here. This line represents a pair of electrons shared between them. And there is single covalent bond between hydrogen and fluorine in HF structure, hydrogen fluoride. And when we look at here is how many bonding pair of electrons do we have? Okay, if so, one line is representing 1 bonding pair, so which means that there is a bonding pair of electrons here. And okay, if I look at the fluorine, this two is not shared with hydrogen. Okay, these are not shared electrons. So we have 3 lone pair, non-binding, non-bonding electrons. Okay, 3 lone pair of electrons. And around 100 hydrogen, how many lone pair do we have around hydrogen? As you can see, 0 lone pair. Okay. What about H2O? I just would like to discuss H2O, and then I can finalize here. Okay, I just would like to discuss H2O. What about oxygen? Let's look at oxygen and hydrogen in the periodic table. When I look at oxygen and hydrogen in the periodic table, and the hydrogen is in group 1 valence electron, oxygen is in group 16, 6 valence electrons. So oxygen around O, there's going to be 6 dots, Lewis diagram, hydrogen 1 dot, okay? And then instead of showing which electron is coming from which one to be able to be shared, and then I said let's use cross for the hydrogens, okay? And the oxygen 1, 2, 3, 4, 5, 6. So we know that hydrogen helium needs 2 electrons, okay? This one already have 1, so each one needs 1 electron. Okay, this one needs 1 electron from outside, and then it will become stable. Oxygen is 6, so it needs 2 more electrons to be able to have 8 electrons, and then it will become stable, okay? It will become stable. And then when we look at H2O is that, okay, this one is going to give 1 electron to be shared, this one is going to give 1, this one is going to give 2. And then what happens is that this dot is coming from oxygen, this cross is coming from this hydrogen, this dot is coming from oxygen, this cross is coming from hydrogen. And then what happens is that this hydrogen has how many electrons now? 2. This hydrogen how many? 2. And then when we look at oxygen, how many? 2, 4, 6, 8, okay? So all of them are stable now. So as you can see is that around oxygen, how many bonding pairs we have? 1, 2 bonding pairs of electrons. Around hydrogens, how many lone pairs do we have around hydrogen atoms? There is no lone pairs around hydrogen atoms. Okay, is there any lone pair around oxygen? Yes, these are not shared between the hydrogen and oxygen. 2 lone pairs, okay, we have around the oxygen atom, okay? That is how we can draw Lewis diagram of covalent structures, okay? Lewis diagram of covalent structures. So I'm going to finalize here. In the next class, what I will talk about is the naming covalent structures, covalent molecules. How do we name covalent molecules, as we discussed before, and then we can talk about. So what I want you to do is that until next class, okay, I share the worksheet with you. Okay, so I want you to draw, first of all, Lewis dot diagram of each element before the covalent bond, as I did it just now, and the Lewis diagram of the covalent bonding on the right hand side for hydrogen, fluorine, chlorine, oxygen, nitrogen, and all other different covalent molecules. Okay, try to do this. What you can do is that while you are trying to do is that you can get some help from internet. Okay, if you just write Lewis diagram for H2, okay, and then you can find examples and try to understand until next class. And then next class, and then what we can do is solve and do more examples. Thank you very much.